This is the eMath PT presentation. I am Qing Guan. In my group is Carl and Sean. For this presentation, we'll be talking about y is equals to a to the power of x. For question 1, a is smaller than 0, and we use a is equals to negative 1. So, on the right, we have a table of values ranging from x negative 5 to x 5. So, from the equations shown, we can deduce that even exponent gives you a positive result and odd exponent gives you a negative result. So replacing x with decimals ranging from negative 5.5 to 5.5, we get values of y is equals to undefined 1 and negative 1. Why is that so? Because we have to revisit the rule 6 of indices, where it states that a to the power of m over n is equals to n root a to the power of m. So replacing that with a value of x, we get negative 1 to the power of 11 over 2, which is equals to square root negative 1 to the power of 11, and that would give an error. Why do we get an error? Because simplifying it, let's say y is equals to x squared. 49 will be equals to 7 squared, and 49 will also be equals to negative 7 squared. However, when you replace y with a negative number such as negative 49, you will never be able to reach that number with x squared, because the negatives will cancel each other out in the case of negative 7, and 7 will also not give you negative 49. So that applies in negative 1 is equals to x squared, which is our example. When you replace it with another number of x such as 4.4, it will return you as 1. For question 2, we have a greater than 0 and a smaller than 1, and a is equals to 0.8. For x, we have ranging from negative 5 to 5 in the table. We have a shape of a curve downwards from the second quadrant to the first quadrant. It never cuts the x-axis, and the horizontal asymptote along the x-axis. The coordinates of the y-intercept is 0, 1, and doesn't cut the x-intercept, and the domain is all real values of x with a range of all real and positive values. For question 3, we have a is equals to 1. We have a table showing a range of x on negative 5 to 5. It's a linear straight line with a gradient of 0, and it never cuts the x-axis. There is no asymptotes, and the coordinates of the y-intercept is 0, 1, and doesn't cut the x-intercept. The region has a domain of all real values of x in a range of 1. For question 4, we have a greater than 1, and we chose a is equals to 5. We have a table of x is from negative 5 to x 5. It touches closely but never touches the x-axis. It curves up and goes at an increasing rate. There's a horizontal asymptote along the x-axis. The coordinates of the y-intercept is 0, 1, and doesn't cut the x-intercept. And there's a domain of all real values of x and a range of all real and positive values. Thank you.